Today's lesson 2.2, and it's going to go back to some of the information from 2.1, the situation with Roy and his tickets and his meals. So I'm going to have you do is go ahead and start 1 through 4. So pause the video, get through 1 through 4. You might have to look back at the Roy situation, and then we'll discuss it. All right, so for number 1, here's kind of what you should have gotten. You can figure out the total cost. It's feasible because 1240 is less than 1360. For the next one, you get 1360. That's feasible. 1360 is equal to 1360, his spending amount. This next one costs 1480. That's not feasible because 1480 is bigger than 1360, the amount of money he has. This last one comes out to 890, but why is it not feasible? It's not feasible because you can't buy 4.5 tickets. You also couldn't buy 4.5 meals, but just because the number is less than 1360 doesn't always make it feasible in a specific word problem. Number 2, for all the ordered pairs, TM, so tickets, meals, that are feasible options, explain why each statement below must be true. All the coordinates in the ordered pairs are integers. We just talked about why they're integers or whole numbers because you have to buy a whole ticket for a whole meal. You can't buy 1.3 meals. You have to buy a whole meal. If graphed in the coordinate plane, all ordered pairs fall either in the first quadrant or on the positive m-axis. So if I have a graph like this and I'm putting tickets and meals, remember, there are no negative meals, so there is not going to be anything down here. There are no negative tickets, so there's not going to be anything over here, which means everything is going to fall in what we call this first quadrant or on this axis because we can buy no tickets, but we do need to eat, so you could have something fall on this axis or anywhere in here. Number 3. Write a linear inequality that represents all the ordered pairs, TM, that are feasible options for Roy. This is probably the hardest one. Not sure how you came about writing yours or how, what form it's in, but here's what you might want to do. $100 per every ticket plus $40 per every meal. That's what he's spending. That has to be less than or equal to 1360. Another thing you might want to also write is not to forget that your tickets have to be greater than or equal to 0. You can't have negative tickets. And same for meals. Meals have to be greater than 0. You could put equal to if you're not going to go get meals. Maybe you're bringing meals. So that one could be either way, I suppose. Number 4, if Roy buys exactly 2 meals each day, determine the total number of tickets he could purchase in 5 days. Show your work. So I'm going to recopy this. I'm not going to put M for meals because it says he has 2 meals each day. If you look back, he's going to be there for 5 days. So 5 days, 2 a day, that's 10 meals. So then when I go ahead and move the 400 over and I solve, I get 9.6. Now this is T, this is tickets. Normally 9.6 rounds up to 10. Does he have enough money for 10 tickets? No, so again, in this situation, it would not make sense to round up. If he only has enough money for 9.6 tickets, he doesn't quite have enough money for the 10th ticket. So you would write down, he could purchase at most 9 tickets. All right, number 5, if Roy buys exactly 1 meal each day, find the maximum number of meals that he could eat. Sorry, if Roy buys exactly 1 ticket each day, find the maximum number of meals that he could eat in 5 days. Show your work. So again, I'm going to start with the same thing, 100. Now tickets, so how many is he going to get? one a day, and there's 5 days. So 100 times 5 tickets plus 40 per meal. Go ahead and solve that on your own, see what you get. After pausing it, you should get 21.5. So round up or down? Well, he doesn't have enough for 22 meals. He has enough for 21.5 meals, so he can purchase at most 21 meals is how you want to show your final work there. Number 6, to see what the feasible options are, you can use a visual display of the values on a graph. Graph your inequality from item 3 on the grid below. So if you would rewrite this for me, 100t plus 40m is less than or equal to 1360. We're going to take our time on this problem. Excuse me. First thing we're going to do is we're going to change the tickets. You can see tickets are on the x-axis. So let's change that to an x and change the m to a y. Now that might be helpful if you want to get y by itself and solve, but here's an easier way to graph this, because if I get y by itself, it's going to take some work. But think about it this way. X, y, or tm in this case. This is called using intercepts. You probably have seen this before. It's an easier way to graph. If I plug in a 0 for x, what will y be? So if I plug in a 0, that's 100 times 0. So that's going to end up being 40y. So 1360 divided by 40 gets 34. I can plot the point 0x, 34 in the y direction, or 0 tickets, 34 meals. If I plug in a 0 for y, that's going to be 100x plus 0, which you don't have to write. Divide that by 100, you get 13.6. So plot the point 13.6. It's a little bit hard to plot. 0. Connect the two. That's a much better way to graph a line given in this form, instead of trying to get y by itself here and getting a y-intercept and a slope. Because if I have the y-intercept and the slope, I'm going to have to do the slope several times to get an accurate line. Whereas doing it with intercepts, I get this point and this point down here. I connect them. All I need is those 2 points instead of repeating the slope over and over again. Now, we have only graphed an equation, but this is an inequality. So it's nice to do what we call a test point. You should have heard that before also in Algebra 1. So either we're going to shade this part or this part. So we do what's called a test point. The easiest test point to pick is 0, 0. So let's test it. If I plug in a 0 for x and a 0 for y, what do I get on the left side? I get 0. What do I get on the right side? 1360. Is this statement true or false? 0 is less than 1360. That's true. So wherever 0, 0 is, which is right here, that's true. I want to shade this side of that line. Okay, so we graph it first using intercepts. Then we pick a test point that helps us shade it. Part B, what is the boundary line of the graph? Well, the boundary line is 100x plus 40y equals 1360. It's the same thing as we had up above, only it's equal, not the inequality, because it's just the line itself without shading. Number C, which half plane is shaded and how do you decide? So go ahead, pause the video and write that out. Part D. Part D, write your response for each item as a point in the form TM. So if you go back to item 4, we talked about the tickets and the meals. So how many did we have? We solved, we got 9 tickets, and that was for 10 meals. Number 5, what did we have? How many meals and how many tickets? So looking at number 5, the number of tickets was 1 a day, that was 5. The number of meals we came up with was 21. Part E, are both of these points in the shaded region of your graph? Well, they worked, so they should be, but you can go ahead and look. 9, 10. Remember, that's 9 tickets, 10 meals. 9, 10 is about right there. That's in the shaded region. And 5, 21. Right there. So yes, they are. All right, going on to number 7. It says, now follow these steps to graph the inequality in a graphing calculator. Replace t with x and m with y. Then solve the inequality for y. Enter this inequality into your graphing calculator. So this is why earlier I had you change it. So let's go ahead and write the following. The original was 100t plus 40m less than or equal to 1360. Then we replaced it with 100x plus 40y is less than or equal to 1360. So let's go ahead and solve for y. Get y by itself. So you're going to subtract 100x on each side. And now you're going to divide by 4. Sorry, not 4. So this is not my answer, but this is getting it solved for y. So now in my graphing calculator, which you should do along with me, we are going to type this in. The reason we couldn't have typed it in before was because y wasn't by itself. If I go back to what we did in number 6, we didn't need to get y by itself. That actually would have taken more time. This little table was much quicker. But if you're going to use a graphing calculator, you have to get y by itself, because if you go to y equals, that's your only choice. So let's go ahead and type 34 minus 2.5x. Now, if you hit graph, here's what's going to happen. Not much. There's 2 problems here. Number 1 is first go back to y equals. Notice this says equals. So we're going to change this right here in our graphing calculator, because it always graphs y equals. We want it to graph y is less than. So the way you do that is you just arrow over to where this is highlighted. Your calculator may look slightly different than mine, but you can still do this. Once you are over here, instead of on the 34, the 2.5x, you're going to hit enter. Again, yours may look different, but what you want to do is you want to change this option to look like this. This would be less than. So we hit OK, or however yours, you might just have to hit enter on yours if you have a different type of calculator. Now hit graph. Now there's some shading, but it's still a big problem. We don't need all these quadrants. Remember, we only need quadrant 1. So let's go to window. X, remember, stands for meals. So the lowest number of meals, the X minimum, lowest meals is 0. The highest meals, if you look back at your graph from number 6, it was 34. I'm going to go up to 36 or 40. I like to go a little bit higher than the maximum. And then for the Y minimum, this is your tickets. What's the lowest number of tickets? 0. Highest number of tickets was, I think that was like 13.6. So let's just go up to like 16. Again, these aren't exact values. These are the window in which you want to see your graph. So if I can get 10 meals, I don't want to go just to 10. I like to see a little bit past that. So go to graph. Oh, let me look at this. X. Oh, I have those backwards. The X's was tickets, so that was 0 to 16 or 13, 14, whatever you want to do. And the Y, sorry, was meals, 0 to 36, 40, whatever you want to go to. There we go. There's our graph. So we have now graphed the same thing we did in number 6, but we did it on a graphing calculator. First, you get Y by itself. Then you change your inequality to less than or greater than, whichever it is. And then you have to fix your window for the word problem. So our X's, sorry if I said it wrong earlier, your X's is tickets, so 0 to 16, or whatever you want to view it on. You could have done 20, that would have looked like, oops, it would have looked like this. So not too much different, just around that number. Okay, going back to this, B and C kind of walk you through that. So we can scroll down through that. Describe your graph. You could describe the intercepts that we have. You can describe the shading parts, all kinds of things you can do there. What I'm going to have you do right now is finish describing that for letter D. Go ahead and pause the video and do 8, 9, and 10, and then we'll talk about them together. Okay, so for 8, it's a little bit of your opinion, but kind of the pros and cons. So the pros to doing the graph on paper is you don't have to get Y by itself. The pros to doing it on a calculator is if you're working with large numbers, calculator does some calculations for you. You don't have to do it in your head. Just kind of describe advantages and disadvantages to each for number 8. Number 9, what part of your graphs represents the solution for which Roy would have no money left over? That would be the boundary line. He's using the maximum amount, those numbers on the boundary line here. What parts of the graph represent solutions for which Roy has money left over? That would be anything in the shaded region. So if I pick a number here like 2, 2, sure, he could buy 2 meals and 2 tickets and he'd have a ton left over. 4 meals and 4 tickets, he'd have a ton left over. Anything in the shaded region here, he'll have money left over. But these maximum values are going to be on this, what we call boundary line here. That's going to give him no money left. He's spending it all. Number 10, explain how you would graph the inequality, either by paper and pencil, or by using a calculator. I would like to talk about it both ways. So for pencil, what I would do if I were going to paper pencil and make this graph, I would do what we call intercepts. I don't need to get Y by itself. What I need to do is find the 2 intercepts. So if X is 0, 2 times 0 is 0. 3Y is less than 12. I can figure out Y really easily. Divide by 3, Y is 4. Hardly have to show any work or think too hard on that one. If Y is 0, 3 times 0 is 0. What would X be? 6. So I plot the point 0, 4, and 6, 0. It's actually going to be a dotted line. We didn't talk about that too much this lesson, but because this says less than instead of less than or equal to, less than is going to be a dotted line, and less than or equal to is going to be a solid line. We talked about that in a previous lesson. Now that I have the boundary line done, now I'm going to pick a test point. I'm going to test 0, 0. The only time you cannot test 0, 0 is if your line goes through it, and then you test any other point. So if I plug in a 0 for X and a 0 for Y, that's going to be 0 plus 0. True or false? 0 is less than 12. True. So 0, 0 works. This is true. So I'm going to shade everything on this side of the line. Actually, this line continues because it's not a word problem, so It doesn't have to just stay in a certain quadrant. So all of this would be how I graph it. Paper, pencil. I use intercepts. I pick a test point. So that gives me my line and my shading. If I use a calculator, the steps would be get y by itself, change the inequality symbol in your calculator to one of those, and then make sure your window is appropriate for what you're trying to view. All right, so that's where we're going to stop for notes today. We'll finish the rest of this lesson tomorrow.